Yo, what's up guys, this is 𝗪𝗏𝗟𝗟𝗟 and today I'm gonna showcase a pawn challenge from UniHack. UniHack is a Greek Hellenic University CTF, so I'm supporting my country. And let's go. Unfortunately, we reached the 5th place right here among other universities. And let's start with pawn. So right here we have 3 challenges. It was a beginner CTF, so don't expect something spectacular. 𝗪𝗔𝗟𝗟𝗟𝗪, and we get this file, we run it. Blah blah blah, let's fuzz it. And we see a segmentation fault, nice, so it must be a simple buffer overflow. DDB, run check, and we see that it has nothing right here. Okay, so if we do info functions, it's a wild guess, we see we have a very secret function right here. It's a very secret function. We see that it calls system at this point. And RDI contains this. What is this? Access this. It's been cut flag. Okay, nice. So at the very end, it's gonna cut flag. What we see here, we see a comparison at the top. The first argument should be code fade, code fade. If the function has this argument first, then it's gonna put some stuff and then call cut flag. And this is our goal. So first of all, I'm gonna find the cyclic offset. Make it 100. So right here, we run the program again, enter it, and we see at the top of the stack we have this. I click that, so this, and we see the offset is 24. Let's start creating our exploit. So I'm gonna have my pawn template right here, double solver, and it's magic return. And I don't have the remote instance right now, so I'm gonna run it locally, and I don't need that stuff. What else are we missing? First of all, we know we have our offset, which is 24, and our dot send line. So we have b a times our offset, and after that we need to construct the argument. So I'm gonna head back here, and our goal is here actually is to call very secret function. Right, functions. Yeah, we have to call this with this argument, just very secret function, and the argument is this. And what we're missing right now, we're missing the RDI gadget, the RDI register, because you have seen my other videos. If you didn't, go check. I explain this stuff very in depth. So the first argument goes to RDI, the second argument goes to RSI, blah blah blah. This should be vice versa, but never mind. So what we need right now is find a row pop RDI gadget, row --dash grep, and right here pop RDI, and we see we have this gadget at this point. So let's say here we have pop RDI at this address, and inside we want this. I'm gonna have my arg1 should be this. So the only thing missing here is p64, and we have pop RDI, and after that we have p64, our first argument, and then p64 e.sim, and we want the address of the function, which is this. Another way to find that is by simply doing the here p very function, and we get this address, but this is the dynamic way to do it. The same could happen with the pop RDI also, but that's showing many ways to do it right here. And after that, if we simply do r.interactive, we should get the flag or not. Let's see why. So let's go. First of all, let's create echo flag GG and run the solver. And we see nothing. Just kidding, but we don't get an output. And why this happens? This happens because it's a stack alignment issue. We need to add a return gadget in between here. How we're gonna find that? Same way, row --dash grep, set, and we have it nice and clean right here. So we go add a return gadget for stack alignment, and if we do Python solver, we see that this time we get the flag. GG. So that was the first challenge. It was a simple red win with arguments and stack alignment. Nice for warm up. Then we have 6-7. Again, I have made a a fake flag for testing right here. And let's see what we've got. 6.7. Let's try A's again. Notice anything suspicious, nothing, and the text we inputted is just echoing back to us. Let's run it again, and this time I'm gonna try some %p. And what we see that it leaks addresses because it's a format string bug right here. We could also see that inside the decompiler or disassembler, but okay, with just some fuzzing, we see what happens here. The basic 7 info functions, we see a win. That's nice. I guess it will simply either spawn cell or give us the flag. Is us main. Okay, we see it calls valn. Does valn. And valn reads our input, prints with the format string right here, and then exits. Okay. So we cannot override the return address. We simply have to do some got override. And see there's partial error, so we're allowed to do that, and I think that's the intended way actually. So what we're missing right here is run the program, and that's p, and we see we start overriding at this 1, 2, 3, 4, 5, and 6 on template 6, 7. So we know that the position we override is 6. So let's say so the offset is 6, and what we actually want to do r.sendLine, and we're gonna use from Pawn Tools the 𝗪𝗪𝗪𝗪𝗪 payload. The arguments are, I think first it's the position, and then inside this we have the address we want to override. So e.got_exit, the address of exit, and we want to override it with e.got_win. I guess this seems right. And also at the end, we want the size, right size, and it's gonna be sort. Then r.interactive, and we run the solver. Ooh. And we say flag GG, so we actually managed to get the flag. Also, if you don't know what happened here, the format string happens because of something like this. Instead of doing a %s, I don't know, name, buffer, whatever. Instead of that, the author did something like this. So this way, if you do the %b, s, d, whatever, you start leaking stuff from stack. So this is why it happens to leak the addresses back. And the format string payload right here is from Pawn Tools, and it will do the override because with %n, you can actually start writing stuff, but this implements it all magically. So yeah, again, if you have questions about that, you can check my other videos. I have showcased this many times. Yeah, that was the second challenge. Let's proceed. Okay, this one was a bit tricky for me, and it's the only one that I lost first blood. So let's run it. We see we get a cell, ls, have this, okay, cat, get nothing, of course. And if we run help, we see pysh version, blah blah blah. These commands are available: help, ls, date, wmi, cwd, env, and hostname. Okay, and let's try some stuff. Okay, segmentation fault. That's nice. So we actually managed to override something. Let's see. Sec, first of all, no canary, no py. That means we can abuse the buffer overflow we found. And let's see what it does in functions. We see a nice main right here. That's main. And we see set vbuff. Okay. And then it calls get and run command. Does get and run command. I'll zoom out a bit. Okay, so right here it actually allocates all this space, and then it prints something, and then we see a gets. So this is where the buffer overflow occurs, and then str_talk to what we have, input we gave, then compares it, and then string copies that, send printf. Okay, so we fire the challenge in Ghidra right here, analyze. Okay, functions, we start with main again, and we see, actually. Okay, so right here we see that loaded all the stuff, hostname, blah, blah, blah. And we go to get and run command. And here we have the buffer, local 120 way. Okay, I hope this is visible. Okay, so it allocates all this space right here, blah, 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 blah. And gets, so this is our input right here, _compare, this is the result, compares this local _talk. So this is the _talk res counter. Okay, so right here it kind of breaks, splits them. Let's say split, and this is our CMD at the end, what is gonna be executed. It's gonna take argument, parse it as argument inside this command, Python 3 --c, and the command we give it. Then it gonna, not here, this is the CMD. So this is the command, all this, it will be put inside CMD, and then it will run system CMD. And it will run Python 3 -c, let's say ls, if ls was the first argument from the string we gave it. So first of all, we have to find the overflow offset. Hit back to the debugger again and see get and run. And okay, so here is our get, and it saves it in rbp minus this. This is this, and rbp +8 is the return address. So it's gonna be this. I'm disgusting.
Disgusting!
This is gonna be the offset for the buffer overflow. And let's start crafting our payload. Phone template, table solver. Okay, we have piece here and true echo flag. Okay, so we have the offset at 522. We actually need to do right now, we want to call something like this, say gets, and inside we want something somewhere to write. So I'm gonna take the BSS segment for that. BSS segment is actually something writable. First of all, let's try and craft that. So payload will be BA times this. Then our payload should be plus equal p64. In order to call that, we want first the _RDI. I'm going to db this pop -- grep _RDI and clean. Okay, so this is our RDI gadget. After that, we want the BSS region. So I'm gonna do BSS plus something, whatever. So we don't write on stuff that we shouldn't. Then payload plus equals p64 BSS. Okay, so what we actually managed to do here is overflow the buffer, execute this, and then write inside there. And what we're gonna write, so what we actually managed to do here is we call gets, and we write inside the BSS segment. And after that, what we wanna do is actually do this, call system with this. And inside BSS, we're gonna store the string 𝗙𝗟𝗟𝗟𝗪. So this will actually give us cell. And how we're gonna do that? Payload should be p64 it.got system, but before that we want again pop RDI, and inside RDI gonna have this. Here I forgot to mention that we want p64 it.simp.got. Oh my god. Yes. So this will call this, and that will call that. I think I got a stroke doing that and explaining that. And at the end, our send line, and we want in sh with a null byte r.sendLine payload r.interactive And if everything went smoothly, this shall give us a cell. Please, for the love of God. Nope, I messed up somewhere.
A few moments later.
I'm a fucking animal. Oh, okay, so this way we managed to get cell and read the flag. Because I didn't have an offset. I have the wrong offset right here. For some reason. I didn't even know why do I have it here. So yeah, that was, I think it was the most difficult challenge from the pawn category. And yeah, that was a solution. We actually abused the first buffer overflow with gets. We call again gets with PSS as the writable segment where we want to store our payload. After that, we continue by calling system with PSS as the argument, first argument, where we have written the string 𝗙𝗟𝗟𝗟𝗪. So this is what all actually does. So these were the challenges, guys. I hope you enjoyed them. I also like them, even though they were beginner friendly. So don't forget to subscribe to the channel to support me. Have fun and see you in the next video. Bye.